spend a big bit of our time on today is this idea. I'm going to make a little note, and this is it. Complex solutions come in pairs. So you get the value for S, and you get the other value, which we call its conjugate. So you really are getting S, and it's a complex conjugate S bar. So whenever you have one, you've got a second one. If you don't, something went wrong. Let's try this. We're going to solve y double prime minus 2ay plus, this is kind of a unique one, but you'll see in a bit, a squared plus omega squared equals 0. Yeah, that's it. We're going to solve that. Looks big, doesn't it? Because it is. What are we going to do? We're going to try the exact same thing. Let's try the exact same thing. So try. And I'm not going to write y null. In this case, we only have a null solution, so we'll say y. We'll try y equals e to the s t. Okay? Well, we already know that we're going to have y prime. It's going to be e, or it's not. It's going to be s to the s t. It is s e to the s t, and y double prime is s squared e to the s t. Yes?
Did you say that this only has a null solution?
Yeah, it's only equal 0. There's no forcing term.
So even though a squared plus omega squared, you can put that on the right.
Oh, you know what? Oh, let me fix that. Thank you. Great question. I knew something was wrong when I was writing. There, now it's the null solution. Is that better? I was so excited to solve it, I forgot to write what I was going to solve. Okay, let's solve this. Now what's going to happen? Let me do this a little faster. Because what's going to happen is I'm going to put in a y double prime. That's going to give me an s squared e s t. For y prime, I'm going to put in an s e to the s t. And for y, I'm going to put in an e to the s t. What am I going to factor out of all three terms? E to the s t. So really the problem is reduced to s squared minus 2a, y prime is going to just be 2as plus a squared plus omega squared is 0. Well, I should say this. Maybe I could add this. That's a good question. Let I'll just do this. A and omega be constants. So we're trying to find x. So maybe I should write that. That wasn't fair. Find x. And don't just circle it and say, here it is. Got it. That's right there. Now look, this is a quadratic. Sure. And that's all it is. Quadratic. Use. I know, you always thought it was all about parabolas. Actually, the whole reason you had a quadratic formula was so you could take differential equations. That's it. Now you know. It just took you 3 years to get there. They just hold that out all that time. You're like, what am I going to use it for? What do I use it for? Differential equations. Now your teacher is going to answer that. All right, so finally, use the quadratic formula. Use the quadratic formula. So let's do that. We're going to write it out. Simple, and then we'll clean it up. S is equal to minus the b term, which is minus 2a. So that's going to be plus. I'm going to have a 2a. Plus or minus some big square root, I suspect. The square root of b squared. So that's 4a squared. Minus 4 times the a term is 1, and the c term is a squared, plus omega squared, all over 2 times the a value, which is 1. Yeah. Yeah, the a meaning it's made a of the quadratic, which is this position, which is not the a, but next to the 2. The a's. Texture. Oh, look at this though. If I distributed minus 4, I'm going to get a minus 4a squared. So 4a squared minus 4a squared, that's 0. So I'm left with, inside of this, a minus 4 omega squared. So I'll write that. So that's going to give me a 2a plus or minus the square root of minus 4 omega squared over 2a. I'm sorry, over 2. Over 2. This is going to be equal to. Oh, look at that. This is 2a plus or minus I times 2 times omega. Oh gosh, that just cleaned up so nice. I didn't see that coming. Over 2. Factor out a 2 from every single term, and my answer, what is this? My answer is a plus or minus I. But wait a minute. How many solutions did I get for this? I have 2, and what are they? S. S is a plus I omega, and what the other solution is always S bar, good, which is equal to the complex conjugate of S, a minus I omega. So remember that, they always travel in pairs. Joe?
Could you switch, like which one is S and which one is S bar? Or is there a specific reason we chose the positive one to be S?
You could, yes. But the traditional notation would be this. This is what you're going to look. If you're going to look in a book, this is usually the default choice to write it this way. But I think, however, if you're dealing with a problem like this, 1 over 1 minus I, then its conjugate would be 1 plus I. And so you might have seen the problem written as 1 over z times z bar over z bar. So this would be backwards from this, but the idea still applies. So again, you kind of are going to use it just based on the way the problem is set up. But when you're solving quadratics, you tend to see the plus. And then like,
So if you put S bar, just be red by S.
yeah. Okay. Oh my gosh. Let's write our solution. I almost forgot. This is all to find a solution, and our solution was y equals some constant c1 e raised to the a plus I omega, all of that is in parentheses, times t, plus c2e raised to the a minus I omega quantity, all that times, and that's our solution. That's so that leads me to the question of today. And that's what we're going to do, is we're going to examine e to the a plus, parenthesis, a plus I omega. Yeah, just that. That's all we're going to do. Just going to look at that. No, I'm going to put a T. Sorry. There. Examine E, A, I, plus I omega. That's what we're going to do. Come back over here. So let's do it this way. I'm going to write this as E. Let's examine. Let's examine E raised to the. I'll write the whole thing. A plus. I omega times t when omega equals 1. Okay, so that's going to give me e raised to the a plus I. So let's keep going with this. So this is, notice that this number has two parts. This is a complex number. Okay, so this is a complex number. And all the rules of exponents that you've learned still hold. So if I have something plus something, let's clean this up so it's a little easier to see. What if I write this as e raised to the a t plus I t? Well, if I do that, and then I apply my rules of exponents, this is the same as e to the a times t times e to the I. Questions there? Okay, let's take it one step further. One step further says that is Euler's identity. This is going to be e to the a t parentheses cosine of t plus I sine x. So, the graph. I'm gonna do this in pieces. Do this in pieces. I think you'll understand why as we go. I'm gonna call this first part capital A of t, and the second part here B of t. It's just for simplicity. So I'll call this capital A of t will be my function e to the a t. And capital B of t is cosine t plus I sine t. Let's do this. First, graph B. First graph. B of t. So in order to do this, I'm going to make a table over here. So we're going to graph that. I'm going to take up all of that space. I'm going to take up all of this space. So make sure you've got some room on your page. You've got your room for your graph, room for a bit of a table. And here's what we're going to use for our table. Let's do this. I'm going to we're going to try t. I'm going to put a line under this. We're going to start, this may seem a little counterintuitive, but we're going to start with b of t. Then we're going to come back and we'll address a of t in a moment. So notice that, so t, e a times t, you can put anything in here and it just explodes. But putting anything into cosines and sines is quickly a mess, right? Like the cosine of 2, most of us, I don't have it memorized. Does someone know the cosine of 2 off the top of their head? Okay, so it's probably not a good choice. I think a better choice for these would be, intervals of pi, like maybe pi over 2, pi over pi, 3 pi over 2, and 2 pi. And so let's just do that. So let's start at 0. And then we're going to go to pi over 2. And then we're going to go to pi. And then we're going to go to 3 pi over 2. And finally we'll try 2 pi and let's see what happens. Okay, if you have colors, this might be a good problem. Alright, so b of t, and we'll write this out just so you can see it. This is the cosine of 0 plus I sine of 0. Sine of 0 is 0. Cosine of 0 is 1. 1 plus 0 is 1. Is that right? Okay. Let's see. Oh, well, we'll do another one. So here, let's do the cosine of pi over 2 plus I times the sine. Pi over 2. Cosine, that's going to be a 0. Sine of pi over 2. What's that? Is that 1? Oh, dear. So this is going to be a 0 plus I. Huh.